All right, so next up, we are looking at the distributive property. Okay, so basically, what the distributive property is, it's a method that you can use to get around a certain part of the order of operations. Okay, so when we look at some of these problems and we talk about simplifying them, so we kind of scoot down here, looking at this, order of operations says that we have to do parentheses first. But the problem is that x and -4 aren't like terms, right? Because this one has a variable and that one doesn't. So we can't follow normal of order of operations here. So the distributive property is something that we can do instead of following our normal order of operations to simplify this a little bit. Okay, so to illustrate how this thing works, we're going to take a look at this picture here and talk about two different ways that you can find the area of this figure. Okay, so two different ways to find the area of this rectangle. So we know that to find area, you do length times width. So there's two different things that we could do. The first thing that we could do is that we could say, well, I can find the area of this box right here, and then find the area of this box here, and then add them together, right? Because I know if this is 3, then so's this. So I could find the area of this box and say, well, the area is 3 times 2, right? And then add to that the area of the second box, which is 3 times 5. So that's one way that we could calculate the area of this. Now, the other way that we could calculate the area of this shape would be if we look at it as one big shape. So if I look at this as one big rectangle, like that, well, this side length here is obviously 7, right? If that's 2 and that's 5, then the whole thing is 7 long. Okay, so then this is 3 times 7, right? Which we got by adding the 2 and 5. So what I could do instead is I could multiply 3 times the 2 plus 5. And if I do either one of these two things, I'm going to figure out the same area for this shape. Right? So what that tells me is since doing this and doing this gets me the same answer, that means that these two things must equal each other. Okay, and this is where our distributive property comes into play, because if you take this number on the outside, the 3, and you distribute it to both the 2 and the 5, then we get what we have up here. Multiply the 3 by the 2 and get this part, and then multiply the 3 by the 5 and get this part. And it's adding, so it stays adding. And that's what the distributive property is. Okay, so when we look at this without looking at it as an area, here's what we can do. This guy right here, I can look at and say, okay, well, I can take this -4 and I can distribute it. And to do that, I'm going to multiply. So just like we multiplied here, we did 3 times 2. So I'm going to do -4 times 3. 4 times 3 is 12. And then we think back to our multiplication division bear, right? So if I'm multiplying a negative and a positive, that means that my answer is going to be negative. So that'll be a -12. And then -4 times -2. 4 times 2 is 8. And I'm multiplying a negative and a positive. So a negative and a positive, my answer is going to be negative. And then I can simplify that. So -12 minus 8 is -20. Okay, and that's what the distributive property does. Now you might be thinking to yourself, Miss King, why did we do that? Like, why didn't we just add the 3 and the 2 together? For this problem, we totally could have. You're right. Okay, the other thing that we could have done for this problem is we could have said, well, let's add together the 3 and the 2, and then this will become -4 times 5. And what's -4 times 5? Well, 4 times 5 is 20, and a negative times a positive is a negative. So we get to the same answer either way. This way, following order of operations is shorter and quicker, but using the distributive property gets you to the same spot. Okay, so when I look at this guy, now the difference between these two problems, like we said before, is that here I can add these guys together and follow order of operations if I want, but here I can't. Those two aren't like terms, so I can't follow the order of operations. So instead, I'm going to take this -1 and I'm going to distribute it. So I'm going to do -1 times x, so that's just going to be -1x. And then -1 times -4, 1 times 4 is 4, and a negative times a negative is a positive. So that'll be negative 1x plus 4. Or you could write it just as negative x plus 4. That's the same thing. Okay? All right. This guy down here, same deal. We're going to do our distributive property. So I'm taking this number on the outside, and I'm distributing it. 5 times 2 is 10, so that's going to be 10x. 5 times 3 is 15. So that's 10x plus 15. Okay, and then this guy over here, this one, there's more in the parentheses, but that's no big deal. We can totally handle that. I'm just going to distribute this one more time. So I'll distribute to the 3x and the 4y and the 1. So 2 times 3x, 2 times 3 is 6. Okay, 2 times 4y, 2 times 4 is 8, so it'll be 8y. And then 2 times 1 is 2. And that's it. That's our distributive property. Okay, so it's not super hard. You're just taking the number on the outside and you multiply it by everything in the inside, whether there's only 2 things on the inside or more than 2 things. You just multiply by everything on the inside. And that is the distributive property.